In this video lesson, we'll look at factoring polynomials using specifically greatest common factor. In this video lesson, I'll look at more complex types of polynomials. But before we get to the complex, let's look at the more simple ones. So we were working with 6x squared plus 9x cubed. Finding the GCF, understand if you said GCF, greatest common factor, backwards, actually the first part is factoring. So what I'm going to do is take each term and put it in factored form or an expanded form. So 6x squared, 2 times 3 times x, while the 9x cubed, 3 times 3 times x times x times x. So now that everything is in factored form, I can begin to look and identify what's common. We can easily see that the 3, the x, and the x are common to both. So my common factors right now are 3, x, and x. When I put all of that together, that creates the greatest common factor. More specifically here, 3x squared. So now that we've found a way to get our greatest common factor, it's now time to factor out the GCF, which essentially says we'll remove the 3x squared from each of the terms and see what's left over. So there's our original problem in factored form. Right now we know that the 3x squared is what is common. So that's what's going to be factored out. And when we take out the 3x squared, we can see what's going to be left over. We'll be left over with a 2 from the first term and a 3 and an x from the second term. So when we write our answer, we'll have the GCF on the outside and what's left over on the inside of the parentheses. In essence, when factoring out the GCF, you're essentially using division. So there's my original problem, 6x squared plus 9x cubed. The GCF is 9x squared, 3x squared, my apologies. Each of our two terms will be divided by our GCF. So I wrote out the GCF here, and when we divide the first two terms, we end up with 2. Divide the second two terms, we end up with 3x. I got the 2 because 6 divided by 3 is 2. X squared divided by x squared, that cancels out. 9 divided by 3 is our 3. X cubed divided by x squared is simply x. If you recall, when dividing like bases, we simply subtract the exponents. 3 minus 2 gave us the 1. So there's our answer, and we did a process with dividing as opposed to putting it in expanded factored form. Now I got my answer. I can actually check myself by actually doing a distributive property. 3x squared times 2, 6x squared, and 3x squared times the 3x, 9x cubed, which was the original expression. So now we'll look at a more involved problem. We'll do the exact same thing we did before. Is first I'll put it in factored form. So my first expression of x squared times x minus 3 to the 1/4, actually in expanded form is simply x times the x minus 3 to the 1/4. While the second term of the 4 times x minus 3 to the 5/4 in expanded form, you've got the 4 and you've got 5 of the x minus 3's to the 1/4. So I got 1/4, 2/4, 3/4, 4/4, 5/4. So once you understand how to put this in expanded form, in factored form, we can then begin to see what's common. We can easily identify that x minus 3 to the 1/4 is a common factor for each of the expressions. And so therefore, my greatest common factor here will simply be x minus 3 to the 1/4. So just like before, now that we have our GCF, it's time to factor it out. So my GCF is my x minus 3 to the 1/4. And let's see what's left over. Well, in my first expression, I'll have x times x, which would give me my x squared. While in the second term, I've got a 4 And I've got an x minus 3 to the 1/4 4 separate times. So there's 1/4, 2/4, 3/4, and 4/4. 4 times x minus 3 to the 4/4. But of course, 4/4 is the same thing as 1. So when I simplify that, I'll eliminate this 4/4. So we're almost done with our answer. This 4 times x minus 3, that can be distributed. So the 4 to the x and the 4 to the technically negative 3. So when I distribute that, that'll give me 4x minus the 12. So I've just taken my original expression and factored out the GCF. We're going to take this exact same problem and consider another option, an optional way of finding our answer. We can see now that they both have a common factor of x minus 3. So instead of me expanding this with a bunch of x minus 3's, what I'm going to do is this. I'm going to just let this x minus 3 be a random variable u. And so that when I begin to expand it, I won't have to involve a bunch of x minus 3's. So when I rewrite this problem, there's my x squared. Instead of x minus 3, the letter u. There's my x minus 3, the letter u. So it's just to kind of maybe simplify things as we begin to work a little further. So when I put this in expanded form, instead of a bunch of x minus 3's, I got a bunch of u's. Here I can see that my common factor is u to the 1/4. So my GCF here is u to the 1/4. Being reminded that that is technically x minus 3 to the 1/4 because u and x minus 3 are interchangeable. And so when we start to factor things out, when I factor out the u to the 1/4, I'm still left with 2 x's, x squared, I should say x times x, x squared, and I'm still left with 4 and 4 of these u's to the 1/4. So 1/4, 2/4, 3/4, 4/4, 4/4. Of course, that 4/4 is still going to be a 1. So now I have the same problem I had before, but instead of a bunch of x minus 3's, we substituted with a u. Now that we've gotten this far using a little bit more simplified version, we can now replace the u's back with the x minus 3's. So there's my first x minus 3, and there's the x minus 3 multiplied by 4. Now we can proceed by distributing that 4 and ending up with our simplified answer. So this is the exact same problem, but instead of leaving all of the x minus 3's, kind of simplified to a single letter. So we're going to do the same problem, but now we'll consider what we did earlier on instead of putting this in expanded form. So again, we're going to let the x minus 3 equal to u. Got my new problem, substituting the x minus 3's with the u's. But this time, again, our GCF is still u to the 1/4. But this time we're going to factor the GCF without writing it in factored form. So you want to be able to have the level of expertise that you aren't dependent upon writing all of this out. And so, if you recall, when we factor out the GCF, we are essentially dividing each term by the GCF. So there's each term, and we're going to divide each one by the GCF. Well, if you recall, so we're going to divide these two terms and these two terms. Our rule said back early in algebra, when dividing like bases, simply subtract the exponents. So the first two terms we're going to divide, the exponents are 1/4 and 1/4. So the arithmetic will be 1/4 minus 1/4, 0. That's why these two will cancel out. The other will be 5/4 minus a 4th. 4/4, which of course is still equal to 1. And so when we divide each of these two, we'll have our GCF of the u to the 1/4. When we divide these two, the u to the 1/4 cancel, leaving me with my x squared. And the 5/4 minus the 1/4 u to the first, and I still have my 4. And so now, we've done everything we could with the u's. Now it's time to substitute, replace the u's with my x minus 3's. Like before, we distribute and simplify. So there's my answer. So again, we found the answer without writing it in factored form. So we'll do one more example. We're going to do the same thing and use the u. We can see that the x minus 3 is common, so we'll let x minus 3 equal our u. We'll rewrite the problem with the u's. So there's the x squared. Instead of x minus 3, there's the u. Instead of x minus 3, there's the u. Hopefully you'll be able to see that what's common is the u to the negative 1/5. What you don't want to be is distracted by this negative. Essentially, whatever this is, that'll be your GCF. And so, if this is my GCF, again, we're going to attempt to factor out the GCF without writing it in expanded factored form. So, which means we'll take the original problem, and everything will be divided by our GCF. These two terms will be divided, and these two terms will be divided. Again, our rule says when dividing like bases, simply subtract the exponents. So in this case, we'll be subtracting negative 1/5 minus another negative 1/5, and 4/5 minus negative 1/5. 5/5 gives us our 1. And so which means our u's will cancel here, and we'll only be left with u to the first, or just u. So my GCF we said was u to the negative 1/5. We're left with the x squared here. We're left with the 4 and 1u. We've simplified, so now it's time to just substitute wherever we see a u. We'll put back the x minus 3. And in the second version of it, we can see that we'll distribute again. 4 times x, 4x, 4 times the 3, the 12. So hopefully this gives you a better understanding of how to find the GCF, or at least factoring using GCF for much more complex problems, and especially problems that have a fractional exponent.